All right, so in this video, we're going to go over the concept of sampling and parameters. But before we do that, since this is our introduction to statistics, I think it's worth our while to define what statistics is. Well, statistics is the field of study that investigates the collection, the presentation, the analysis, and interpretation of data. So stats is about how do we collect data, how do we present that data, how do we analyze that data, and how do we interpret what the data is trying to tell us. All right, so with that being said, a good place to start is what are the different types of data that we'll come across? All right, so the first type we'll discuss is called a population data set. So a population is a collection of all entities that are being studied. And what you need to know for now is that it's very rare that you're able to collect a population data set. It is very rare that you're able to collect everything that you need to study. Instead, what we often do is we collect a sample. So a sample is just a subset of the population, meaning instead of collecting all the information, we're going to collect just some of the information. All right. So what is the data? Well, the data are the individual pieces of information that are collected from either the population data set or the sample data set. There are two main types of data that can be collected, and we'll get into this in a later lecture. For example, suppose we were contacted by a statistical consulting firm and asked to determine the mean age of a college student in Orlando. What would be the population in this case? What are some potential samples? And what's the data that we're working with here? Okay, first things first, what is the population for this scenario? Well, remember we said the population is a collection of all entities. So the population data set here would be all Orlando college students. And as you can imagine, it's very difficult for us to go and get information from every single college student living in the Orlando metro area. What's a possible sample? So there's several different ways we can collect samples. I'm just going to give you some examples here. Some samples could be, we could just collect just male college students. Okay. Or we could do just female college students. Or we could look at just a particular college. Okay. Or just, what about Valencia college students? Just put VC students. Okay. These are examples of samples because they do not represent all college students in Orlando. Okay. What are the data? What's the data? Well, the data for this will be the individual ages. Individual ages of the people that we survey. Okay, so populations and samples are collections, those individual pieces of information, that's what we refer to as the data. All right, so now we're going to get into parameter versus, statistic. That's a typo there. Okay, so a parameter is a numerical description of a population. On the other hand, a statistic is a numerical description of a sample. So basically the two definitions are very similar. It's just the difference is what are you addressing? What are you trying to describe? For instance, if we find the mean age of all college students in Florida, or excuse me, in Orlando, and let's say that mean age is just 25. Well, that mean age of 25 is describing a population, therefore it would be called a parameter. On the other hand, if we're interested in finding the college, the mean age of all college students in Orlando, and we look at just the students in Valencia College, and let's say that mean age is 22. Well, In that case, because we took a sample, that number 22 becomes a statistic. So a very easy way for you to know which goes with which is a little bit of alliteration. Just match up the letters. Parameter starts with a P, population starts with a P. Statistic starts with an S, so does sample. Here we go. For example, got a few examples here. So suppose we want to calculate the average GPA of Valencia College's 68,000 students. Okay, so here we go. Suppose, the first example, suppose we surveyed a random sample of 10,000 Valencia students and calculated the average GPA to be 3.1. This GPA, is it a statistic, or I'll say stat for short, or a parameter? Well, you have to go back and understand, what is that GPA describing? That GPA is describing the 10,000 Valencia College students, which is a sample. Therefore, that 3.1, that GPA, is a statistic. As I said, I'll just write stat for short. So because we were dealing with the sample there, that's why we have a statistic for the 3.1. Next example, what if the GPA for all 68,000 students is 2.9? What is the GPA in this case? Now, since we're dealing with all of the possible students, now that 2.9 represents a parameter because we're dealing with a population. Okay. What if the GPA for East Campus is 3.4? How would you classify the GPA? What's very important here, and what you guys are going to hopefully learn throughout the semester, is that context is very important in statistics. What I mean by that is the context is that we're trying to measure the GPA for all Valencia College students. Well, we know that there is more than just one campus within the Valencia College system. So because we're looking at just East Campus out of the entire Valencia College system, what we're dealing with there is a sample. Even though we're looking at everybody within East Campus, it's still a sample because the greater context, the broader context, is that we're working with the entire Valencia College system. So because of that, East Campus will be a sample for this. Therefore, that 3.4 represents a statistic. However, I know it may be confusing. However, if we were trying to calculate the mean GPA for all of East Campus students, then now the context has changed, and now that 3.4 would actually become a parameter. So hopefully you understand the difference there. All right, so the next thing we want to discuss is how do we collect this data? How do we collect this data? So I call these sampling methods. And I'm just going to give you just the basic four that we'll discuss this semester. But the first one I'll talk about is sample random sampling. Okay, so sample random sampling is something where each member of the population has an equal chance of being selected for the sample. All right. What I mean by that is that there is no inherent bias in your selection, meaning everybody has an equal chance of being selected. For instance, a classic example is, let's say that we wanted to figure out the most popular alma mater in the Orlando area. Okay, or excuse me, in the nation. Let's say we want to figure out the most popular college in the nation. And let's say we go down the street to UCF and we ask people that are leaving from UCF, what's your favorite school? Most of them are going to say UCF. In that case, what we have is bias, because if we're trying to, get information about the entire nation, just going to Orlando itself is not going to do us very much good. So instead, what we could do is, let's say we had phone numbers of everybody all across the nation. Let's say we randomly select a phone number to call. So we may call somebody in California, somebody in Texas, somebody in New York, North Carolina. In that case, because we did that random sampling, it eliminates that bias that we had before where we did not call different people or survey different people. So that's what simple random sampling is. So examples are, like I just told you, random numbers. How do you just randomly select somebody? Lotteries, okay, or old school. Put names in a hat, shake up the hat really well, and then pull out a name. Those are examples of simple random sampling. Okay, the next two types of sampling are easily confused, so I'll try my best to differentiate those for you. But stratified sampling, what you do is you take the population and you divide it up into subgroups. All right, so let's say our classroom is our population. I could divide the classroom up into males and females, freshmen and sophomores. I could divide people up by their majors. Those are creating subgroups. And then once we have our subgroups, a random sampling is performed on randomly selected subgroups. What that means is that once I have my subgroups, I can choose all of my subgroups or some of my subgroups, doesn't matter. But the difference between stratified and cluster, which we'll talk about in a second, is that what do you do with the subgroups that you have? Well, if you perform a random sampling on the subgroup, meaning you ask some of the people within the subgroup, you've performed what we call stratified sampling. On the other hand, cluster sampling begins with the same way. You divide your population into subgroups, and then you randomly select some of those subgroups. But then once you have your subgroups, now if you ask everyone within that subgroup, which we call a census, if I ask everyone within that subgroup, I've performed cluster sampling. So that's the difference. Both stratified and cluster have subgroups. Stratified, you're only going to ask some of the people within your selected subgroups. Cluster sampling, you're going to ask everyone within your selected subgroups. And then probably the easiest out of all of these is systematic sampling. And what this is that you're just asking every kth member, or you're selecting every kth member of the population. Right? Think of an assembly line. Right? You're on an assembly line, you want to select every fifth item to inspect. Okay? Or I ask every third person walking through a door, what's your favorite color? That's what systematic sampling is. Okay, let's see if we have some examples here. All right, so once again, let's say we want to calculate the average GPA of Valencia College's 68,000 students. And so what are some different ways we can collect that data? So here we go, first example. Suppose we separate the students by gender. So we've created subgroups, so that automatically means it's either going to be stratified or cluster. We then take a random sample of 1,000 male and female students. What sampling method was used? Well, we created subgroups, and we took a sample from those subgroups. Therefore, the sampling method that was used is stratified sampling. Subgroups, sampling, stratified. Okay? Let's go back. Suppose we separate the students by gender once again. We then survey all of the female students. What sampling method was used here? Well, once again, we created subgroups, and then we select the subgroup. And so the fact that we chose just the females to work with, that doesn't delineate whether or not this is stratified or cluster. Okay, whether you select all of your subgroups or some of your subgroups, that's not the difference between stratified and cluster. It's what do you do with the subgroup? In this particular case, we asked everyone within the subgroup. We asked all of the females. Therefore, this is what we call cluster sampling. Then lastly, what if we collected a GPA of every 10th Valencia College student? How would you classify the GPA? As a statistic or a parameter? This is what we will call, or excuse me, that's a typo. What was the sampling method used here? Okay, the sampling method used here would be systematic. Okay, so sorry about that. So ignore what I have written there. So if we collect the GPA from every 10th Valencia College student, we have performed systematic sampling. All right, folks, this is just our introduction to statistics. I hope this helps you out with your homework. I'll see you guys in the next video.